Hello together. Nice that you're here for the talk about middleware API gateway in a RESTful world on top of vert.x. So I'm from Post. This is a project we developed internally, and then we open sourced it at one time, yeah, because we thought it could be usable for other people too. So first, let us go into the buzzwords. So first we called it middleware, but actually what we do is also known as API gateway in the microservices world, as I discovered later. So middleware, yeah, is an old term. It comes more from the old world, and in the new world what we are doing is more called like an API gateway. We don't do everything what is considered as API gateway, but a lot of the things. So you see also in the trending partner signs, microservices are trending. This is also very trending. Then RESTful, we see that it is trending since a long time. It's getting bigger and bigger, so more people are doing it. Then vert.x is a quite new technology. As you can see, it appeared around 2012. And since then, it has some traction. It's not that well known when I talk to people, but it works very well and is in a very stable state. So let's go to vert.x. What is vert.x? What can vert.x do for us? First of all, vert.x is non-blocking. This is a big paradigm shift in the programming model. The ones that know Node.js, they know how it works, how it feels, because it's exactly this. You can't block the thread. You have one thread, and you can't block it. So you get an event in. Normally that's over network, TCP, HTTP, you can also UDP, whatever network you can use inside vert.x. You get that event, you do some processing on that event, and you send something out or back. Now, what is very important also for this concept, all the I/O has also to be non-blocking. So the file system access, non-blocking, network access, non-blocking. Where is the problem? JDBC. There are no non-blocking JDBC drivers. There were no non-blocking JDBC drivers available. Now vert.x is providing some of them. Yeah, of course, the NoSQL databases, they all have non-blocking drivers, but the old world doesn't fit that good yet in this concept. The foundation of vert.x is Netty. vert.x is not that big project. Netty is doing the heavy lifting, and Netty is this asynchronous I/O library that cares about all this stuff under it. The name for this construct in the vert.x world is a vertical. This is a unit that works for you, that does your work, where you can put your code in, and yeah. So these verticals, you can have multiple verticals, and they work together in some way. You can choose how they work together. So here we have 4 verticals, and how we communicate between the verticals is over an event bus. So we send events to other verticals, and they get the events, they can do something with the events, can send events back. And yeah, this is very simple concept. So there are no thread pools like in classical JEE application servers. We have a better scalability with that. We never block a thread, so we can optimize the thread count to our cores. Normally, we instantiate as much verticals as we have cores, and then our machine is optimally used, our processing power. The event pulse supports publish subscribe for multicast. We have also point-to-point, or we have request response protocol. This thing is also fully asynchronously, so we have no problem with concurrency, but also we have, or we shouldn't have, shared state. You can have shared state, but it's not a good practice. So we really should see that we get all the state out of our code. So when we see, so one of these boxes, I call it boxes, runs inside a JVM. This is the inside JVM cluster of the verticals. But then we can also have multiple JVMs, and they also form a cluster together, and they communicate over the same event pulse. For us, this is transparent. The cluster will start up for itself. It will try to discover other vertex instances. It will form this cluster and provide the event bus for us. For us, it's fully transparent. When we send the event, where it will go. Will it go to a vertical inside our JVM? Will it go to a vertical outside our JVM in another JVM? Of course, you have some latency when it goes to another JVM because the bus is working over TCP/IP. For the programming model, this changes a lot when you know traditional Java development, because you don't have this functional style. I call function XY and I wait, I get the result, and then I call the other function. You do everything with handlers, so like Node.js. People familiar with JavaScript, they know how it will look. You have to pass the function, the handler, that will be called when in the future the result is available. So what were our use cases? Why we decided to use vert.x? So one of our use cases is parcel delivery. The postman delivers the parcel to the home, and we have a process, and along this process we have a lot of events. And the postman has a scanner, and he scans all these parcels all the day in the distribution center when he delivers it. And there's a lot of postmans on the road, like around 17,000 a day, so a lot of requests you can imagine. So here we see this big picture. We have this new scanner that was rolled out. And then the scanner is communicating somehow with backend systems. We have a lot of backend systems, newer ones, legacy ones, but we all have to connect them to the scanner, or the scanner have to connect to them. So here, yeah, around 20,000 scanners are on the road. Then that means we have like 100 requests per second that we have to deliver into the post data center. And the 17th of December 2015, we measured 5.5 million requests per day. And yeah, we wanted an infrastructure that can serve this, this volume efficiently. And with the classical J2EE servers, that's not so much possible. So we were looking, or my colleague, better, I came later, was looking for an alternative. He discovered vert.x, and vert.x fitted perfectly in this picture. The next use case is the post buses. The whole information system inside the post buses and also in the data center will be redone. It's redone right now. So what we have inside the post bus, now we have a central processing unit, And we have different sensors and actors that are communicating with this central processing unit, sends data, gets data, sometimes from the data center, sometimes from actors, or sometimes also signals from actors have to go to the data center. And this stuff also makes a lot of traffic, and also this traffic is sent over this central vert.x instance to our data center. In the data center, the same. We have a vert.x instance that is processing all this traffic and distributes it to the backends. Here we talk about also 100 requests per second. So this was the case for Gateline. Now we will see what Gateline is providing us on top of vert.x. So the first main feature is routing. We have to route requests. This is the typical API gateway requirement. You have incoming requests, and you have to distribute them to backends, and you don't want to expose all the backend APIs one-to-one to the client. You want to mask them somehow. So what you can do, you can say URL XY route to this other URL. Then you can also say like only the put, only the get, only this and only that, or do it like this. Of course, the backends also can. I mean, now it's from left to right, but it doesn't matter. I mean, it's input output. Everybody can go to the server and say, I send a request, then we have these routing rules, and the router will deliver. The point here is we have to know the identity of the receiver at config time, at startup time, when we use the router. We will see afterwards how we can also handle dynamically components that just come with an identity IP and then disappear and appear again with another IP. So for these routes, we already needed some configuration possibilities. This configuration, we don't have it statically, we have it dynamically. So we needed a REST storage. And the second case for the REST storage is caching. We have a lot of backends that are not able to serve the load that they have to serve for the scanners. So the backends, they just push their data on daily basis into this cache REST storage, and then is there at the front to be delivered fast to the clients. Then the queuing system. What is the problem? When we have a scanner, then we send a request, and this request should go until to the backend, and something is going wrong, or perhaps it takes too long, and this we can't work with that. We have to send requests really fast, and it has to succeed. So we built a queuing system. That means the request will go into the server delivers 202 created, and then Gateline will take care that this request will be delivered to the backend system. So the backend can be down, or some other problems can be in the data center, but our request is safe because these requests are the data. This is business data. We can't afford to lose these requests. Then the hooking system. This is the part where you can dynamically route to devices that appear and disappear. So you can say, yeah, I want to listen on this URL. I want to get all the traffic that is going over this URL. So you can build your own URLs. So the simplest use case is a chat room. So you can say, I create chat room 2067, and then everybody who want to listen on this chat room can hook on this URL, and he will get all the traffic. for the components, so the REST storage is a own module that can be deployed independently. Is a own vert.x module. The queues is also our own vert.x module. And Gatelean itself, it needs the REST storage to work. It doesn't need the queuing system, but the REST storage at least it needs. And yeah, we have also other features like authorization, user handling, monitoring, quality of service, scheduling, e-tag for enterprise readiness. So let's see the routing. Here we can see how we put a routing rule. This routing rule will put direct into the REST storage and will be available immediately to route traffic to the backends. So when we put now something on this foo bar, we get a 200 OK, and it will be forwarded to this backend. So now when we want to get something into the queue, we just add a HTTP header with XQ. We want to get it in the queue, so the Gatelean will behave differently. We get a 202 accepted, so it's not delivered yet, it's just in the queue. And inside the system, one of the threads will get the request. It will be stored directly into the storage that we don't lose the data. And then it will send the event to all the consumers. We have multiple consumers that can handle the request then. It will send out the event. Is there any free consumer that can process the request? One consumer will say, I'm free, I take it, I will process it, get the request, delivers it to the backend. If delivery was successful, delete it. Now the REST storage itself, you can see here, when you want to not deliver it to a backend, when you want to deliver it to the storage, you just add the attribute storage. The REST storage itself is, you can think a little bit like a file system. I mean, it has the slash notation. You can put a resource under this URL with the slash notation. You can put multiple resources then, and this will be stored as JSON in the REST storage. But you can also put other media types. It's not only JSON you can store, but JSON is the most used. So then you get this structure, this tree structure. We can get the resources back from the REST storage. When we get a parent node, then we get the collection of the resources that are under the parent node. Behaves like ls on Linux. When we get data, the same, we get all the children nodes. Now what we also have, we can also expand. So when we know that all the sub-resources, the children are JSON, then we can tell the parent expand 1 or also 2, 3, how much you want, and then we get it all in one. We implemented this for performance reasons, but because sometimes we don't want to make requests for every sub-resource, so we have to fetch it all together. The deletion works also over HTTP as expected, and then things will be deleted. Now the hooks. Here we have this this chat I was talking about. You see, you have the URL that we want to listen hook onto, then underscore hooks that tells Gatelean register a hook on it, then listener, I'm a listener, and my ID is John, and the destination where all the traffic should go to. In the background, this also uses the queuing system, so when traffic is coming in on this URL, it will be also queued, because the problem is that the destination could disappear perhaps, or Gateline could, perhaps there is a connectivity problem for like 10 seconds or something, so we can't deliver it immediately. So we have a short time where we also queue all the requests and try to deliver to the endpoint. So we chat something on this URL, we get OK, and you see it will be forwarded to the registered hook. So yeah, that's it. Swisspush.org. This is our website where we publish open source stuff from post-IT. You will find the project on GitHub with all the documentation. Slowly we migrated all the documentation, so now it should be better. In the meantime, it's also available on Maven Central. The point is you don't get a ready-to-start server when you download the components. So you have to build your server with the components first. This is one vertical where you have to register the modules and write the main HTTP server. So, but for this, we have also a project or a module is a Gateline Playground where you already see how to write a server. You can use this server to test it out. I work on it to get the Docker image ready that you can just download it and run it. REST storage already is available as standalone Docker image, so you can just pull it and run it, and you get a fully functional REST storage. So that's it. Thank you. Any questions? Yeah.
Thanks. I'm just curious what kind of storage you're using.
Yeah, in the moment, file system and redis is supported. File system we used from the beginning just to make it work, but for production we use redis because of speed. But to be honest, I would like to see something like MongoDB also, because redis, yeah, is not for every use case the best. It's just for fast delivery, it's good, but when you need more stability on the data, then it's not the best. Yeah. Okay. So thank you.